Oklahoma. It's a beautiful day to begin the celebration of what Jesus did for us. So today is Good Friday, and obviously Lent, I guess, was the start of that celebration, but we're getting ready to culminate it this weekend, which is pretty cool. So today we've got another riveting topic, trace minerals. But this is something that we need to kind of slog through here as we look at your health and kind of how you work and what's really important. So what are the important inputs for you to consider as you begin to improve your health? So we're going to talk through trace minerals. And just to recap real quick before we get into this, so again, we're recommending that everyone should be, I guess my hands go the other way in front of the camera, I gotta get that down. We're recommending that everyone should be intermittent fasting, just as a health tip and a health tool. We've done a couple of videos about intermittent fasting, so that's sort of step one. Step two is, as you intermittent fast, you need to begin to understand the importance of what you're putting in your body, right? So food becomes more important, and we need to really boil food down to, what's important to a cell. And I know that doesn't taste good necessarily or sound like it's going to taste good, but if we understand what's necessary for a cell, then we can give ourselves everything that we need to be able to run our bodies proper. And we're going to kind of do what we should, and we'll begin to improve if we're, in a health situation. We'll begin to improve no matter what. So even if you're in great shape, maybe you run, marathon a week, all that, this will still help you. It'll help you recover. It'll help you, function better, right? Because that's what we're doing. That's what we're sort of about, is to help you function better. So again, step one, intermittent fasting, super important. Don't care if you're an athlete or not, doesn't really matter. Everyone should be intermittent fasting. The most damaging and chaotic thing that you do to your body every day is eat, okay? So we need to be a lot more intentional, a lot more thoughtful about that, and then a lot more thoughtful kind of about what we eat. So along with what we eat, there's a drill down there, but dietary fats are really important. So saturated and monounsaturated fats in balance. You need to probably have more monounsaturated than saturated fats in your diet. And none of us do right now if you just eat normal. We need to have omega-3 and omega-6 fatty acids, but in balance. Right now we eat way too many omega-6 fatty acids because of corn. So, those fats, super important. Amino acids are super important. We covered that in a previous video. Today, we're going to talk about trace minerals, and trace minerals are really important, and we'll kind of go through the variety of reasons that they are. But they're, again, your cells can't really function without these trace minerals, and you don't need a lot of them, but you need some of them, and they're really important. We'll kind of walk through that, and we'll also walk through where you get these in food. But I wouldn't trust our food supply anymore. I mean, unless you just know, like if you're eating beans, if you're eating fish, if you're eating meat, the stuff that we can get, from those, it's hard to, take those out of our food supply, I guess. But pretty much if you eat a lot of processed food, you're not getting trace minerals, hardly any at all. And trace minerals have sort of been leached out of our food supply. But they're really important. So, and the fourth thing in what you should eat, really vitamins. And the fifth thing, the last thing, is fiber. So we'll cover all of those, through weeks, because we just need to have that on record, and be able to go back and point people to these videos. So this is one of those on trace minerals. So it won't be super duper exciting, but we need to do it. So we need to talk about it. So here we go. Let's kind of dive into trace minerals. Okay, so what are trace minerals? Well, if our body doesn't get enough of these, or if it gets too many of these, then we increase our risk of disease and other medical problems. And so for these reasons, minerals can have a significant impact on blood pressure, weight management, cancer prevention, depression, pain, PMS, and digestion. I don't know why PMS got thrown in there, but okay. To name a few, sodium, potassium, phosphorus, magnesium, sulfur, and calcium are minerals we are probably more familiar with, but trace minerals are also important, though we need them in much smaller amounts. Trace minerals include iron, chromium. We're going to go through each of these: copper, zinc, iodine, magnesium, and selenium. Cobalt is in there, potassium is in there. Trace minerals have essential functions, including the following: being crucial building blocks for hundreds of enzymes. Okay, so if you can't, and in particular, zinc is really important in how we build enzymes, facilitating a multitude of biochemical reactions. So these trace minerals, all of the metals especially, help us move ions around. That's really, really important, in all the way down to how you generate fuel in your electron transport chain. Being a requirement for normal growth and development, as well as neurological functions. So again, you can't build proteins, and cells can't work, let's just say. They can't do their job, which is to build proteins, if they don't have the required trace minerals. They definitely support the blood system, so every little bit of hemoglobin inside of you has got a chunk of iron in the middle of it. Being required for normal gonadal development, so sexual stuff. If we want to be able to reproduce, we need to have trace minerals. Okay, so first one we're going to go over here is calcium. And we'll go through each of these in a little bit of detail, but I'm not going to read to you everything that has calcium in it, but you can sort of look at the wheel over there and how much calcium is in certain things. So you've got a little bit of calcium in broccoli, you've got a lot more calcium in sardines. Again, milk is not on the 5 things that you kind of need to do here, eat. Milk is up to you. There's better sources of protein, I would say, than milk. Milk is good for baby cows. That's what milk is good for. Calcium is the most abundant mineral in the body. It is used structurally to build bones and teeth, and also as messenger in cell signaling. In addition to forming the primary structure of our body, the bones also serve as a calcium reserve in case of dietary deficiency. I look at a lot of people on scans and stuff, and just almost everybody has some kind of osteoporosis, meaning that we're all leaching calcium from our bones, and that looks to be a pretty common event with all of us, because we're not kind of getting the calcium that we used to get. Dietary calcium is therefore extremely important to prevent loss of bone. Calcium balance, which is what I just said. Calcium balance is maintained by parathyroid hormone. So your thyroid hormone is what maintains your calcium balance in your body. Again, cells work with calcium, so it's super duper important. Every cell needs calcium. Every single cell inside of you needs calcium at certain times. The U.S. recommended daily allowance of calcium is 1,000 to 1,200 milligrams per day for adults. So that's a gram. That's a fifth of a teaspoon of calcium that we all need, just calcium isolated. So you can see how many milligrams you get, like from collard greens. So 252 milligrams. I don't know how many collard grams were in that. Probably a gram. So you would need to eat, 5 grams to 6 grams of collard greens, if that makes sense. Okay, phosphorus is another one. So again, you can see what has phosphorus in it over on the food wheel, and how much it has in it. Pumpkin seeds, interestingly, show up on this a lot. So pumpkin seeds are a pretty good thing to eat. Raw pumpkin seeds, if you cook them, again, you sort of change the chemical properties of them. Phosphorus forms a part of the bones in the form of the mineral hydroapatite. It is also used in cell membranes and is part of the energy molecules adenosine triphosphate, that's your gasoline, and adenosine diphosphate, that's kind of your gasoline, when you get one more phosphorus on there. DNA and RNA also contain phosphate. So again, everything in you, every cell has to be touched by phosphorus. Phosphorus is super important to your energy, how you generate energy. It's also super important to making and building RNA and DNA, which is sort of the purpose of a cell. Okay, magnesium. We don't have the RDA of phosphorus on here. Huh. Well, I'll look that up for you. I'm not sure what that is, but it's it's going to be significant. We use almost as much phosphorus as we use calcium, so I'm going to guess it's going to be 1 to 1.2 grams, somewhere in that neighborhood, because it's used everywhere and everything. All right, so magnesium is another very, very important one. Really interestingly, we put iron in the center of our hemoglobin. If we were a plant and the same process is in a plant, hemoglobin is analogous to chlorophyll. I guess most people don't really realize that. So chlorophyll is kind of like a plant's blood. And it's exactly the same as our hemoglobin almost, except chlorophyll has a magnesium center, and hemoglobin has an iron center, which is interesting. But it technically, we could probably run on chlorophyll, rather than hemoglobin. So it does the same stuff, moves oxygen around and sort of moves, chemical mediators around and immune mediators around and all that. So anyway, magnesium is a really interesting metal. Light is sort of, it's more reactive under light situations, whereas iron is more reactive under more physical situations. So you can take that for what it's worth. Magnesium is widely used by the body for, I know things, so I get to secretly smile to myself. And I'm trying to teach you guys things too, so you are a light being, trust me. Magnesium is widely used by the body for metabolic processes. Some of its main functions include energy production, synthesis of biomolecules, and as a structural component of cell membranes and chromosomes. Magnesium is also used as an ion transport, meaning how your body moves ions around, electron transport chain, all that. Cell signaling and cell migration. The RDA for magnesium is 400 to 420 milligrams for men and 310 to 320 milligrams for women. So a little bit different needs. Again, women, or men, I guess we use more magnesium than women. That's interesting and unusual. There's not a lot of things that we use more than women, just because women kind of can do more stuff than we can, like have babies. All right, sodium chloride and potassium. So this is the wheel over here is for potassium, but these kind of go together. So sodium and chloride are critical life-sustaining minerals. Again, without them you die. Sodium chloride, salt, is a required part of the diet. Salt is antimicrobial, antibacterial. I don't know if you know that or not, but it is. With potassium, sodium and chloride maintains charge gradients across cell walls. So again, you need this stuff to be able to be ionic and electric, which you are. Sodium helps to maintain proper blood volume and blood pressure. So yeah, salt is used, and another hormone called aldosterone are used to balance your fluid levels, okay? So if you retain a lot of fluid, then you probably are also retaining salt, right? So salt kind of has to do with how much fluid we'll retain. Most adults require between 1.5 and 3.8 grams of sodium chloride per day. So that's a lot of salt. That's a full teaspoon of salt, okay? Somewhere in there. In addition to acting as an electrolyte in the body, potassium also functions as a cofactor for a number of enzymes. Low potassium levels can be dangerous, resulting in fatigue, muscle cramps, and abdominal pain. Adults need about 4.7 grams of potassium per day. So again, you can look over here at the wheel, and let's say you decide to eat spinach today. 4.7 grams, that's going to take 10 grams of spinach, right? So that's a lot of spinach. None of us eat that much spinach probably, when we sit down to eat a meal, right? So we might be eating the stuff that you see on these wheels, right? All of these wheels. But are you eating enough? And that's the thing that I want you to really begin to think about. I think we're going to be better off, honestly supplementing, and we're going to build a supplement, obviously, here soon. But I think we're going to be better off supplementing for fats, aminos, trace, vitamins, and some fiber. And then it really doesn't matter what we eat, right? As long as we're sort of supplementing in and we're getting enough of those things, then we can eat for taste past that, because we'll be getting, sufficiency in the stuff that we need. Okay, so iron again, you can see lots of stuff has iron. Mainly, red meat is beef. There we go. Not as much as you think though. 29 milligrams. And again, we need 18 to 26. It looks like milligrams. So a gram of beef is probably enough. But iron is in everything, right? Iron is in the most abundant metal, on Earth. So iron is found in the body in the form of hemi-iron and non-hemi-iron. That's bound and non-bound. It's I think Fe2 and Fe3, but hemi-iron is bound. Yeah, hemi-iron is bound within a ring-like molecule called porphyrin. Hemi-iron is present in red blood cells. Non-hemi-iron, such as iron sulfur clusters, proteins, are used in energy production and other metabolic functions. The RDA of iron for men is 8 milligrams, for women is 18 milligrams, and for pregnant women is 27 milligrams. Okay, manganese. You guys probably are, you know exactly where your sources of manganese are every day. I certainly do. And again, this is stuff that we need to pay attention to. I eat a lot of cashews, so I get a lot of good stuff from the nuts that I eat. But again, I need to be supplementing with these trace minerals, and that's part of why we're just going to build a supplement, because it's you have to just eat all this stuff, and a lot of this stuff that again we don't do now, right? So we don't, how many dried figs do you eat a day? How much mackerel, right? So the functions of manganese include antioxidant activity in the mitochondria, assisting enzymes in metabolism, bone development, and wound healing. Adequate daily intake of manganese is 2.3 milligrams for men and 1.8 milligrams for women. Deficiency of manganese can lead to osteoporosis, diabetes, and epilepsy. So the other thing that's interesting, these guys are sort of tied together. So again, manganese kind of hand in gloves with calcium, right? And helps with everything there. It helps build enzymes. Okay, so copper is the next one. Copper you don't need a lot of, so you can see 800 down at the bottom, 800 micrograms. And so there's, we probably are getting enough copper. It's really not one that we're probably deficient in, but again, we need to pay attention to it, and we need to understand kind of where it comes from and make sure we're getting it, because copper is a cofactor for certain enzymes involved in energy production, connective tissue formation, and iron metabolism. Copper deficiency can be caused by poor nutrition, poor absorption, or excessive zinc intake. So this is one of the reasons why you don't want to you want to be careful, I guess, when you do supplement with these things. So you want to do it within suggested, let's say, how you take them, dosage, but we don't say dosage because it's a natural product, but suggested amounts that you need to take every day. So if you're taking a trace mineral supplement, or you're taking like zinc, let's say, you need to be sure that you're taking that zinc in the right ratio and not taking too much of it. Otherwise, it's going to affect your ability to deal with copper. The US RDA of copper is 800 micrograms, so that is less than a milligram. So that's not much, right? So not much at all. For adults, copper is found in shellfish, nuts, seeds, and whole grains. Okay, iodine is our next one. I think iodine is zinc is our last wheel. Iodine is a critical mineral in the body. It is a component of thyroid hormone and is required for normal thyroid function. So if you guys have been told that you have thyroid dysregulation, if you're losing your hair too fast, if your teeth are you're losing your teeth too fast, could be iodine. Definitely could be iodine. And again, none of these things should happen. We shouldn't lose our hair before we die. We shouldn't lose our teeth before we die. Our eyesight shouldn't go bad before we die. And the reason that all those happen is we're bacterially hijacked and we're deficient in this stuff. Might not be trace minerals, might be aminos, but we're deficient. And so our bodies just can't do. Every cell is always trying to be perfect, right? So again, if it doesn't have the juice it needs, it can't be perfect. And part of the juice that they need are trace minerals, and in particular iodine. Additionally, in the U.S. and many other countries, salt is fortified with iodine to prevent deficiencies in the population. So this was such a problem, when they began to process food, that they had to put iodine in salt, and most you'll find that most salt, in our stores is iodine fortified. Iodine deficiency can cause brain damage, mental retardation, hypothyroidism, goiter, and other mental health problems. The U.S. RDA of iodine is 150 micrograms. So again, that's not much, but you need it every day. Okay, this isn't like I'm I'll eat a bunch of iodine today. I'll eat a gram, and I won't have to eat it for a week. No, it doesn't work that way. Zinc plays multiple roles in the body, is involved in many cellular metabolic processes, and is used in growth and development, the immune system, neurological function, and reproduction. Zinc fingers are associated with everything. It also forms a structural part of cell membranes and is a component of the zinc finger proteins. I really didn't do that on purpose, which act as transcription factors. So again, as you begin to take DNA and transcribe that into proteins and mRNA, you need zinc fingers in order to do that. The US RDA for zinc is 11 milligrams for men and 8 milligrams for women. Men need more. That's interesting. So men need more manganese and zinc. I didn't really realize that. Now I do. Well, I learned something under Chip Talks. Cobalt, fluoride, and selenium. Cobalt is present in the body as part of vitamin B12, which is involved in manufacture of blood cells and nervous system function. Cobalt is also pretty important in your immune system, and again, it's one of those guys that, it's vitamin B12, so if you're taking a vitamin B supplement, make sure that it's got B12 in it, but it's also an important trace mineral. Fluoride is an important trace mineral. Again, fluoride hardens tooth enamel and stabilizes the mineral in bones. Natural sources of fluoride include tea, fish consumed with the bones, and some fruit juices. However, the major source of dietary fluoride in the U.S. is fluoridated drinking water. The average fluoride intake per day in areas with fluoridated drinking water is 1.4 to 3.4 milligrams. In areas without fluoridated water, it is 0.3 to 1 milligram per day. There's lots of arguments about fluoride, again, it's up to you, but fluoride is something that you need because like it says, it hardens tooth enamel and stabilizes the mineral in bones. The natural sources of fluoride would probably be better, but again, some fluoride is probably going to be in a trace mineral supplement. Selenium is super important to hair growth, which I'm just sort of realizing. So I've been taking selenium. I started taking selenium maybe a month ago, and I'm just going to see what it does to me and to my hair, but that's kind of an interesting experiment. Selenium functions in the body in the form of selenoproteins, which have many metabolic functions. The US RDA for selenium is 55 micrograms. Foods rich in selenium include Brazil nuts, tuna, oyster, pork, beef, chicken, whole wheat bread, and milk. Deficiency of selenium does not usually result in obvious clinical illness, but may contribute to Keshan's disease and Keshan-Beck disease. So the fact that I want to sort of walk you guys through something. So, a lot of these trace minerals are found in meat, but they're only found in the meat if the meat ate the trace minerals, okay? So, if you go slaughter a grass-fed cow that's only been grass-fed, a cow's going to have a lot of this stuff that's expected, right? It's going to have a lot of the right vitamins. It's going to have a lot of the right trace minerals. It's going to have the right ratios of fat and stuff that you would expect. If you go to a feedlot, a cow that's been feedlotted all its life, grew up in a feedlot, was fed corn the whole time, they're not good. Their meat will not contain what you think. Their meat will be deficient in things that they were deficient in. So if it's selenium, it's selenium, okay? But we need to realize this, and as we sort of look for sources of things, and I'm not saying don't eat meat. I like to eat meat. I'm going to keep eating meat, but I'm not going to look to meat for any of the nutrients that I'm looking at. I'm just going to look to meat for taste. I'm going to make sure that I supplement with all the things that I think that I should be getting from that meat, okay? Because, again, there's I want to say the F word, but I won't. There are, you know, let's say there's people have messed with the system. Let's just put it that way. Okay, so all these guys are important to eat, but again, there's things that affect absorption. This URL reference down at the bottom, I know it's a little cryptic, but you know, you might write that down. It was a pretty good article on absorption and absorption of trace minerals, and it also went into a lot of detail about trace minerals and kind of what you can use them to help with certain things, you know. And again, we need all of these all the time, so we shouldn't be, you know, oh, I think I'll use manganese to, you know, or magnesium to poop, right? Yeah, it's, you know, we need to kind of all of them together, and if we're healthy, then we're not going to have any problem pooping, right? All right, factors that affect absorption. So mineral bioavailability is defined as the degree to which the amount of ingested mineral is absorbed and available to the body. So how much can I get in you and how quick? This means that even if a food containing the mineral is present in the diet, the mineral may not get into the body. You may not absorb something. You may just poop it out, right? And so, you know, again, we want to give our bodies what it needs. Our bodies are pretty good at kind of figuring out what they need. And if it doesn't need something, it's just going to let that move on through. So you're not going to uptake, you know, a bunch of stuff you don't need, I guess is the best way to say it. I can get you to uptake things that are bad for you. I'm not saying that. But again, you're generally not going to uptake too much of stuff. Factors that will affect, except sugar, so there's always an exception. Factors that will affect the bioavailability of a mineral. 1, current need. That is the major determinant of bioavailability. So if you need it and it's presented, your body's going to try to uptake it. If the mineral is not present in sufficient amounts, the mineral absorption will greatly increase. So the less you have of something, the more your ability to absorb it increases. Mineral to mineral interaction. So minerals of similar molecular weight and charge will compete for absorption. So that's interesting. So I guess you absorb around charge and weight. I learned 2 things on my chip talks today. That's interesting. Charge and weight. Oh, okay. When competing minerals are present at the same time, they will not be absorbed, and what gets absorbed and how much cannot be predicted. So again, if you've got competition around weight and charge, it's kind of a crapshoot as to what you'll pick up first and how much. For example, magnesium, calcium, iron, and copper all have a 2+ valence, so they would all compete for absorption if they were present. 2 frequently consumed minerals in the pill form are iron and calcium. They both have a 2+ valence, so consuming these together will decrease the absorption of one or both. Any other minerals with 2+ valence are magnesium and copper. So again, if you take any of that stuff together, unless you take it in a natural product, so magnesium, copper, and iron. This is interesting, so this may go into some product design. Sorry to get wrapped up in the weeds, this is just how my mind worked. Okay, so third thing, vitamin to mineral interaction. So vitamin C increases the absorption of non-hemi iron, iron from plant foods. Calcitrol, which is vitamin D, good stuff, is required for calcium absorption. So calcitrol is required for calcium absorption. So if you don't have vitamin D, you're not going to absorb vitamin C. Yeah. And calcium. Man, fiber to mineral interaction. So this is good stuff, obviously, and there's more competition here than we think, and more competition here than I really realized as I was putting this together. So I'm sorry for the pauses, but this is extremely important in how we take these in. So again, if you're taking a bunch of 2+, that's going to cause problems. You need to take the 2+s one at a time. Probably, but you know, this deserves further investigation. So sorry about that. But when I'm building you a supplement, when I'm building a supplement that I'm building for my wife, for my family, or my kids, I want that supplement to work, and I want it to work in a proper way. So this is telling me that, you know, supplements designed in a certain way won't work as well as they should. All right, fiber to mineral interactions, components of fiber. Okay. components of fiber, like phytic acid, found in grain fiber, can bind minerals and limit absorption. So phytic acid is in lots of grainy plants. So again, this is going to limit your ability to absorb these minerals. Oxalic acid, found mainly in spinach, Swiss chard, beets, strawberries, rhubarb, cocoa, and soy, will bind calcium and decrease absorption. So oxalates, you've heard a lot about oxalates, so this is kind of a reason why we want to watch our oxalates. High fiber diets, greater than 35 grams, will decrease the absorption of at least iron, calcium, and magnesium. So we all probably need to eat more fiber. I don't think any of us are really in that category right now. But again, if you're iron deficient, calcium deficient, or magnesium deficient, you might want to look at your fiber intake. So if you eat a lot of fruits and vegetables, that would affect you. And not a lot of meat, let's say. When bioavailability makes the absorption of minerals difficult, most of the minerals can be quite toxic in the pill form. Some of the toxicities result from higher intake of the minerals being consumed, and others result from disturbances that arise when the megadose of the minerals causes a decrease in absorption of other minerals. So you can't just take a whole bunch of everything all at once. Minerals are found in both plant and animal foods. The animal sources tend to have greater bioavailability because there are fewer inhibitors present, and the mineral content tends to be more concentrated. The one exception is magnesium, which is found only in plant products, as magnesium is found in chlorophyll. All right, so that was some pretty good information. Some of that was new to me, and some of this is really interesting about a really interesting thing that, so if with autism, and again, I pay attention to autism, and I'm coordinate, let's say, kibitz with a lot of autism researchers and autism folks around the country that are concerned about solving the problem. One of the things that we're seeing is kids on a keto diet, autistic kiddos on a keto diet, do way better. And again, this may have to do with absorption and high fiber diets, because most autistic kiddos want to eat a lot of fiber, right? They want to eat a lot of potato chips and carbohydrates and fiber, and that would decrease their ability to absorb iron, calcium, and magnesium, which might add to the pathology of the disease. Okay, so some parting thoughts. This has to do with just selenium. And this is, if you can read that down in the bottom left, military strategies for sustainment of nutrition and immune function in the field. So let's go to what they're studying soldiers for efficiency, and our soldiers have to stay alive and alert and be healthy. One of the things that they're finding is selenium is really, really important to this picture. So if you look at the graphs there, and this is these sort of, the bigger the bar, the worse the outcome as far as pathology on the left. And so you want a small bar that would indicate more health. And so you can see that the selenium that's been added to diet has resulted in smaller bars. The selenium deficient diets resulted in more pathology, meaning you get sick easier and quicker. This is important on the battlefield. I mean, again, you don't want to have a bunch of sick troops, right? So if you spray COVID on a bunch of troops, you want them to be eating a lot of selenium, it looks like. So you can see there the graph on the right, kind of similar look. But this is from the U.S. military's thinking. So last slide here, some parting thoughts. So this is from a study, and this is actually from that military study, but and I'll just kind of sort of read it to you. But clearly, trace elements have been shown to be important for immune system functioning. A deficiency of copper, zinc, or selenium has immunosuppressive effects on the host, which can lead to increased susceptibility to infectious disease. So again, we're finding that it's all about understanding the power of your immune system, and we need to make sure that we have a lot of power in our immune system. Otherwise, we're going to get infected, we're going to get metastasized, and we're going to get super sick. The usual model for understanding the effect of nutrition on infectious disease is diagrammed as below. So inadequate host nutrition leads to inadequate immune response, which leads to increased susceptibility to infectious disease, which leads to illness. However, this author's work with selenium and CVB3, which I'm assuming is a copper and zinc supplement, demonstrates that host nutrition can affect not only the host, but the pathogen as well. Therefore, the following model is proposed. Inadequate host nutrition leads to an inadequate immune response, which both feed a virus, which can increase susceptibility to infectious disease, which leads to illness. Now, I like that virus and infectious disease at the core of illness because that is the cause of disease. And again, apparently the U.S. military has come to the same conclusions, which is always fun. A confirmation sideways. Anyway, that's it on trace minerals. I know that wasn't, super riveting and exciting, but they're very important to us, and we need to understand them, and we need to understand their importance. Anyway, I will see you guys later. Have a good holiday weekend. Spend some time with your family. Be sure to remember what this weekend is all about.